What would happen if the Earth stopped rotating for a second?
Oh, yeah, that would be disastrous. Disastrous, because right now, here in New York, you can calculate at our latitude, we are all moving with the Earth at 800 miles an hour. If you stopped Earth and you weren't seatbelt buckled to the Earth, you would fall over and roll 800 miles an hour due east. It would kill everyone on Earth. People would be flying out of windows, and that would just be a bad day on Earth.
Right now, as you're watching this video, you're moving at over 1,600 kilometers per hour, and you don't even feel it. That's how fast the Earth is spinning at the equator. You're on a giant rock hurtling through space, rotating at speeds faster than a bullet train, and evolution has made you completely numb to it. But what if it stopped? Not gradually, not over millions of years, just stopped. Like someone hit the emergency brake on a planetary-sized carousel. Spoiler alert, you wouldn't survive to complain about it. Welcome back to Nauzta Lab, where we answer the questions that keep physicists up at night and make NASA engineers nervous. You are watching the second episode of What If series, and today we're exploring what happens when Earth's greatest magic trick, the rotation that gives us day and night, seasons, weather, and basically everything that makes life possible, suddenly ends. Here's something most people don't think about. You're already an astronaut. You're traveling through space at approximately 107,000 kilometers per hour as Earth orbits the Sun. But that's not all. Simultaneously, you're spinning. Earth completes one full rotation every 24 hours, which means at the equator you're moving at about 1,670 kilometers per hour. That's faster than the speed of sound. For context, the fastest jet in the world, the SR-71 Blackbird, tops out at about 3,500 kilometers per hour. You're moving at half that speed just standing still. Well, standing still relative to Earth. Relative to space, you're basically in a high-speed chase scene. Except the chase never ends and you're not the one driving. Now here's the beautiful part. You don't feel any of this motion because everything around you is moving at the same speed. It's all relative. The ground, the air, the buildings, your coffee, everything is synced up in this cosmic dance. But what makes Earth rotate in the first place? Conservation of angular momentum. When Earth formed 4.6 billion years ago from a swirling disk of gas and dust, that spinning motion got locked in. There's no friction in space to slow it down. Well, except for one thing, and we'll get to that later. So, Earth just keeps spinning. And spinning and spinning. This rotation does more than just give us day and night. It creates the Coriolis effect, which drives our weather systems. It generates Earth's magnetic field through the movement of molten iron in the outer core. It causes an equatorial bulge that makes Earth slightly fatter around the middle, about 43 kilometers fatter actually. The rotation is why hurricanes spin. Why toilets supposedly flush differently in different hemispheres, though that's mostly a myth. Why you weigh slightly less at the equator than at the poles. Everything about our planet, from ocean currents to the trade winds that carried ships across the seas for millennia, exists because Earth spins. So what happens when it stops? Well, buckle up. Actually don't. There's no seatbelt rated for what's about to happen. Let's start with the worst case scenario, the nightmare fuel. The reason this thought experiment is actually terrifying. Imagine Earth just stops, instantly, like someone pressed pause on a cosmic remote control. What happens to you? Remember Newton's first law? An object in motion stays in motion unless acted upon by an external force. You've been moving at 1,670 kilometers per hour your entire life. When Earth stops, you don't. If you're standing at the equator when this happens, you would be thrown eastward at 1,670 kilometers per hour. That's Mach 1.4, supersonic speed. You would literally break the sound barrier just by standing there when the planet stopped. It would be like being inside a car traveling at supersonic speed that suddenly hit an immovable wall. The car stops. You don't. You keep going straight through the windshield at Mach 1.4. Except there is no windshield, there's just you, the air, and the sudden realization that physics doesn't care about your survival. You'd be dead instantly, not eventually, not after suffering, instantly. The deceleration forces would be around 45 g-forces. For context, fighter pilots black out at around 9 g-forces. Formula 1 drivers can survive crashes at 40 g-forces if they're in a specially designed safety cell for just a fraction of a second. You're experiencing 45 g-forces with zero protection moving at supersonic speed. Your body would disintegrate. Not metaphorically, literally. The sudden deceleration would tear you apart at the molecular level. You'd be transformed from a person into a rapidly spreading cloud of atoms traveling eastward at Mach 1.4, and you'd be one of the lucky ones, because here's the thing, the Earth stops but the atmosphere doesn't. Air isn't attached to the ground, it's just kind of hanging out above us, held in place by gravity and moving along with Earth's rotation through friction and inertia. When Earth stops, that friction disappears. The atmosphere keeps moving. At the equator, you'd experience winds of 1,670 kilometers per hour. To put that in perspective, the most intense tornado ever recorded, the El Reno tornado in 2013, had winds around 480 kilometers per hour.
Blowing sideways, and there's a tornado next to me. People are gonna die today. Might be me. That's a massive tornado right there. Rapid rain.
Those winds could hurl cars like baseballs. Now triple that, no, quadruple it. These winds would flatten everything. Mountains would be scoured clean, forests would be ripped from the ground, roots and all. Cities would be reduced to rubble, and then the rubble would be reduced to dust, and then the dust would be scattered across continents. The Burj Khalifa, the tallest building in the world, it would snap like a toothpick and the pieces would be sandblasted to nothing before they hit the ground. Even if you somehow survive the initial inertial forces, maybe you're in a bunker, maybe you got lucky, these winds would strip the land down to bedrock. Everything on the surface would be swept away. And it gets worse. Right now, Earth's rotation creates centrifugal force that bulges ocean water toward the equator. The oceans are literally being pushed outward by the spin, which is why sea level is about 8 kilometers higher at the equator than it would be if Earth didn't rotate. When the rotation stops, that force disappears instantly. The oceans would start redistributing. Water would rush toward the poles. We're talking about the entire Pacific Ocean, all 165 million square kilometers of it, suddenly deciding to relocate. The resulting tsunamis would make the 2004 Indian Ocean tsunami look like a ripple in a bathtub.
Death and destruction sweep across the Indian Ocean.
What is happening is worse than science fiction.
It's like a gigantic train wreck. The front end stops and the back of the wave piles in and destroys everything on the shore.
We're talking waves hundreds of meters tall, traveling at jet aircraft speeds, carrying the kinetic energy of entire oceans behind them. Coastal cities wouldn't flood, they would be obliterated. The waves would travel inland for hundreds of kilometers, reshaping continents. And when the water finally settled, the geography of Earth would be unrecognizable. The equatorial regions would become exposed land, vast new continents appearing where oceans once existed. The poles would be flooded under kilometers of water. Earth would have two separate oceans now, disconnected from each other, pooled at the northern and southern ends of the planet. Oh, and while all this is happening, the ground itself is tearing apart. The sudden stop would cause unprecedented earthquakes, magnitude 10, 11, maybe higher. The Richter scale doesn't even go that high because we've never needed it to. The Earth's crust would buckle and crack. Mountains would collapse. Volcanoes would erupt simultaneously across the globe. The mantle itself would shift, creating new fault lines and closing old ones. Entire tectonic plates would shatter. If by some miracle you survive the winds and the tsunamis, you'd be standing on ground that's moving like a ship in a storm, except the ship is made of rock, and the storm is the planet's crust, trying to reorganize itself after stopping from supersonic speeds. And then there's the magnetic field. Earth's magnetic field is generated by the rotation of molten iron in the outer core. That movement creates electrical currents, which create magnetic fields. It's basically a planet-sized dynamo. Stop the rotation and the dynamo stops, the magnetic field would collapse. Not slowly, suddenly. Why does this matter? Because that magnetic field is what protects us from solar radiation and cosmic rays. It's Earth's invisible shield, deflecting charged particles from the sun that would otherwise strip away our atmosphere and sterilize the surface. Without it, we'd be exposed. Solar storms that currently create beautiful auroras would instead deliver lethal doses of radiation. Any electronics still functioning, which, let's be honest, there wouldn't be many, would be fried by electromagnetic pulses. GPS satellites, dead. Communication satellites, dead. The International Space Station, the astronauts aboard would have a front row seat to the apocalypse before their radiation exposure became lethal. So let's review what happens in the first few minutes after Earth stops spinning. Every person at the equator is killed instantly by inertial forces. Supersonic winds scour the surface clean of all structures and vegetation. Tsunamis larger than anything in Earth's history reshape the continents. Unprecedented earthquakes crack the crust and trigger worldwide volcanic eruptions. The magnetic field collapses, exposing the surface to deadly radiation. And all of this happens in the time it takes you to finish your morning coffee. The total extinction of all surface life would take maybe an hour. 2 at most. But here's the really dark part. This is the quick death, the merciful scenario. What if Earth stopped slowly? Let's imagine a different scenario. Instead of an instant stop, Earth's rotation gradually slows over years or decades. This sounds better, right? More survivable? Wrong. It's worse, much worse, because now we have time to watch everything die. As rotation slows, days get longer. At first, maybe just a few minutes added to each day. You'd barely notice. Your circadian rhythm would adjust. We'd change our clocks. But it keeps slowing. Days become 25 hours, then 26, then 30. Your sleep schedule is completely destroyed. Every organism on Earth evolved with a roughly 24-hour day-night cycle. Plants, animals, humans, we're all synchronized to this rhythm. When it changes, everything breaks. Plants can't photosynthesize properly. They need darkness for certain processes and light for others, timed to a 24-hour cycle. Extend that cycle and their biology fails. Crops die, forests decline, animals fare worse, migration patterns break down, breeding cycles desynchronize, predator-prey relationships collapse because everyone's circadian rhythm is haywire. And it keeps slowing. Days become 40 hours, 50 hours, 100 hours. Eventually each day lasts 6 months and each night lasts 6 months, and finally it stops completely. But not just stops, Earth becomes tidally locked with the sun. You know how the moon always shows us the same face? That's tidal locking. One side of the moon permanently faces Earth while the other side is always hidden. The same thing would happen to Earth with the sun. One hemisphere would face the sun forever. Eternal daylight. The other hemisphere would face away forever. Eternal darkness. The sunlit side would bake. Temperatures would soar to hundreds of degrees Celsius, similar to the daytime surface of the moon, which reaches 127 degrees Celsius. Except on Earth, there's an atmosphere to trap and circulate that heat, so it might get even hotter. Any water on the sunlit side would evaporate. The ground would bake and crack. Nothing could survive there except maybe some extremophile bacteria hiding underground. The dark side would freeze. Without sunlight, temperatures would plummet to minus 200 degrees Celsius or lower. Any remaining atmosphere would freeze and fall as nitrogen snow. The ground would be covered in ice kilometers thick. Both hemispheres would be completely uninhabitable. But there's a thin band in between, the terminator zone, the twilight region where the sun sits perpetually on the horizon. This narrow strip, maybe a few hundred kilometers wide, would be the only potentially habitable region on the planet. Temperatures here might be tolerable. Not comfortable, but tolerable. Except there's a problem. The temperature difference between the eternal day side and eternal night side would create the most violent winds in Earth's history. Hot air from the day side would rush toward the cold night side in a perpetual hurricane that circles the planet. Winds of hundreds of kilometers per hour, constantly, forever. The Terminator Zone wouldn't be a peaceful refuge. It would be the battleground where day meets night with Earth's entire atmosphere caught in the middle. Any survivors would need to live underground, deep underground. And even then, what would they eat? All the plants are dead, all the animals are dead. The oceans are either boiling on one side or frozen on the other. You'd have maybe a generation before everyone starved to death. Let's talk about weather for a second. All of Earth's weather, hurricanes, monsoons, trade winds, jet streams, exist because of the Coriolis effect. That's the apparent deflection of moving air caused by Earth's rotation. Without rotation, there's no Coriolis effect. Hurricanes couldn't form, they require the Coriolis effect to start spinning. That's actually good news. Except it doesn't matter because everyone's already dead. What you'd get instead is simple convection. Hot air rises on the day side, flows to the night side, cools, sinks, and flows back. A giant atmospheric conveyor belt with no complexity, no nuance. Boring weather, except boring weather with wind speeds that would make a Category 5 hurricane look like a gentle breeze. Oh, and oxygen levels would drop. Plants produce oxygen through photosynthesis, which requires light. On the eternal night side, all plants die immediately. On the eternal day side, they cook and die. The only plants that might survive would be in the Terminator Zone, and there wouldn't be nearly enough of them to maintain current oxygen levels. Over years, the oxygen concentration in the atmosphere would decrease, breathing would become harder. Animals would suffocate, the few remaining humans would need supplemental oxygen just to survive. And without plants to absorb carbon dioxide, CO2 levels would rise. The greenhouse effect would intensify on the day side, making it even hotter. It's a death spiral, slow, agonizing, and inevitable. So, is there any practical application to all this doom and gloom? Actually, yes. Scientists are deeply interested in Earth's rotation because it tells us about the planet's interior, its history, and its future. By studying changes in rotational speed, we can learn about mass distribution inside Earth. We can track climate change effects in real time, we can understand tidal forces and predict how the moon will drift away from us over billions of years. We can also study other planets. Venus, for example, rotates incredibly slowly. One Venusian day lasts 243 Earth days, and it rotates backward compared to most planets. Understanding why tells us about Venus's formation history and what might have happened to it. Mercury is tidally locked with the Sun in a 3-to-2 resonance, meaning it rotates 3 times for every 2 orbits. Study its rotation and you learn about tidal forces and orbital mechanics. Studying Earth's rotation teaches us how planets work, all planets, including the ones we might want to colonize someday. And there's practical stuff too. Precision timing for GPS requires accounting for Earth's slightly variable rotation. Astronomical observations need to factor in Earth's wobble. Climate models require understanding how water distribution affects rotation. It's all connected, which is either beautiful or terrifying depending on how you look at it. Probably both. So, what if Earth suddenly stopped spinning? If it stopped instantly, everyone dies within minutes. Supersonic winds, global tsunamis, total geological chaos. The end of life as we know it, delivered faster than you can process what's happening. If it stopped gradually, everyone dies over years. Ecological collapse, atmospheric changes, the slow transformation of Earth into a planet with one side baking in eternal sunlight and the other frozen in eternal darkness. Either way, it's not great. But here's the thing, it's not going to happen. Earth's rotation is stable, it's slowing, yes, but at a rate so gradual that humans will be long extinct or evolved into something unrecognizable before it becomes a problem. The universe is full of catastrophes, but this isn't one we need to lose sleep over. Instead, we should appreciate what we have, a planet that spins at exactly the right speed to give us day and night, seasons, weather, a magnetic field, and all the conditions necessary for life. We won the cosmic lottery. We're on a Goldilocks planet that spins at a Goldilocks speed in a Goldilocks orbit around a Goldilocks star. And we get to experience it. That's worth celebrating, even if the celebration is happening while we're hurtling through space at 1,670 kilometers per hour. This has been What If, where we ruin your sense of security about basic planetary functions you never even thought to worry about. If you enjoyed this existential crisis, subscribe, hit the bell, tell your friends, misery loves company. Next time, what if the sun disappeared for 24 hours? Until then, keep spinning, both literally and metaphorically. And remember, every day you wake up to a sunrise is another day Earth decided to keep rotating. Be grateful for that. Because the alternative is, well, you just watched 20 minutes about the alternative. See you in the next episode, assuming Earth keeps spinning long enough for me to make it.